Exactly. Except unless they both.
This is a take on the classic. I believe it has something to do with trains, and you have a train and it's on a track, and you're standing at the switch that switches it between left and right lane. And if you
It's on the track. Actually,
it's aimed on one track, aiming a certain number of people, it's going to kill them. And if you pull it, it's going to kill another certain people. Which one do you choose? It's one of those, you can't really make a choice. It's more of a moral dilemma than it is really a true choice thing.
The one I've heard from, and I got this from TED Ed, is basically there's two gingerbread cookies, and they're given that, and the evil wizard fox or something comes down to them, gives them the same option of red and green, and then like if they both like choose green and they each lose one of their limbs from the fox eating that limb, both choose red, they both lose 3 limbs, and if one chooses green, one chooses red, the fox eats the other one. And it's just a very interesting dilemma, and then there's the second part about it I forgot, but it's very interesting.
You spent a lot of time with the one about the fox, the bunny rabbits, and the boat, didn't you?
Oh, is it the what?
The fox, the bunny rabbits, and the boat.
I have no idea what that is.
There's something about.
Oh, I know that one.
What did I tell you? What did I tell you?
No, I've heard it where it's the
sheep, right? Sheep.
That's where I know it.
I know you had heard that before.
Yeah.
All right.
But I haven't heard that from TED Ed.
Yeah, because that one's one that you can actually solve.
But no,
You're giving us ones that have no solution.
This one, the one I saw on TED Ed actually has the answer if you want to look that up. Gingerbread problems. Type that in, it'll come up.
If we have time. All right, questions on homework.
Yeah, kind of.
Number?
7 and 9.
7 and 9.
I know what the answer is because I looked in the back of the book, but I don't know how to.
Okay.
Wow. I probably got those two wrong.
I don't know. I'm not confident on all my answers.
Really?
I'm confident on 1 through 6, 8, and 10, but not 7 and 9.
I could be wrong. I thought this was a pretty easy one.
You said you're not being efficient.
You said, okay, so 7 is the hardest one. Right. What was the other one?
9.
9 isn't too bad. It's just a distance one.
Don't you just have to, don't you just use 30, 60, 90?
Yeah, because you're told it's equilateral triangle.
Then my answer is right.
Okay, so the key there is knowing that it was an equilateral triangle, so therefore it's a 60, 60, 60 triangle, and it's on this. So remember, an equilateral triangle is also, if you look at it this way, it's not an isosceles triangle, but it's that same setup. So this right here leaves half here, which means that this is 30 degrees. So you get a 30, 60, 90 triangle, because the ultimately, I'm sure you got the first part right, that the X value, but it was the Y value that we'd have to do. So it ends up being S root 3 over 2. So let's see how they got that. So you're told at this point right here, so here's your X and Y axis. So you're told this point right here is S comma 0, right? So that means right here, that's S over 2, right? If that's S. And so 30, 60, 90. We know that the short side is, on a 30, 60, 90, the short side is A or S. We'll use S since they used S. Okay, the side opposite 60 is 2S. And the other side is, did we get that backwards?
Yeah.
Okay. And 2S. Okay. So don't care about the hypotenuse, we care about that right there, S root 3. So that means that 2S is equal to S. We got to use different variables. It doesn't work if we use S. So this is A, and this is an A, and this is 2A. Okay. So we are told that A is equal to S over 2.
Yeah.
So therefore,
Yes, S root 3 over 2.
say again?
No. Well, maybe. I think that's root 3.
All we do is take this, plug it in right there. Well, that's this, so we plug it in right there.
Yeah, that's what I got, but I was still.
So it would be S, that's the A, over 2 times root 3. That's it. So that's the Y value. And the X value was, yeah, S over 2. Because ultimately we're trying to find this point right here. So it's over S root 2, I'm sorry, S over 2, and then it's up That's root 3 over 2 because it's 30, 60, 90. And that's how I know that my other class didn't do the homework because none of them asked what would the answer of question number 7 was. Did you get the other part of number 7?
Yes.
There's actually 2 parts.
There was another part?
Yeah.
That was number 8.
What was the other shape 2? Oh, it was 8. That was 8. Okay, got it.
Oh, okay, there. I'm confused.
All right, and 9?
That wasn't that bad.
Try to quadrant. Is it a parallelogram? You know it's parallel or just
Yes,
quadrilateral?
It's a rhombus,
Okay, so it's a rhombus. That means all sides are the same.
which means it's parallelogram.
And all rhombi are parallelogram. Well, that's horrible. All right,
That's
that's close.
beautiful.
We're told this is a comma 0. And we're told that this is something b. And that's it. And we got to figure out that and that.
Well,
And obviously this is
we
0.
already know that the y on the first one's b. Second one, I mean.
Well, it's a rhombus. What do we know about
Second one
rhombus?
that's empty. The second one that's empty. You already know that's b because they're on the same line.
What do we know about rhombi?
Why
There
are you
All them.
Sides are the,
saying?
so from here to here is a. Then from here to here is a distance of a distance. It doesn't mean it's at a, but it's a distance of a. This is your y value. That's what he was trying to get me to say at the very start. So from here to here is b. So from there to there is b. Okay, so we're just left with that distance and that distance.
Well, you got something there. You should draw that. You should draw that line when you're when you're on the x-axis and the going up to that point of blank comma b, the first one.
To draw what?
Yeah, draw that.
Draw what?
So from the point the how do I say this? Draw a perpendicular. No. Yes, the line from that one right there.
Let's label it A, B, C, D. I think they do that.
Or AB.
This is CBA. CBA.
From C, draw a parallel perpendicular line from C to the x-axis. That's the height, right?
That is. But is the height part of these values?
No, it's B.
It's B.
Right, we know the height's B. But now, if you look at that carefully, you notice we have something interesting right there.
Well, we have a right
The
triangle.
difference
And
between
what can we do with the right triangle?
Pythagorean theorem.
And yeah,
But how do we know that distance right there?
it's A.
No. From here to here is A.
Oh, from there to there to there.
you have to figure out.
So how are we going to get the x value basically? We know that this distance right there is A. And that should go all the way to the end.
So you just got to figure out the difference between the origin and the intersection point of that altitude. And then you have to add that. You have
It
to.
is a rhombus.
Wait, if it's a rhombus, then that side right there, the diagonal one's A. That's length A, because they're all the same side.
Yeah, but that's. Yeah, I mean, yeah.
So you just do.
Oh yeah, it is.
So you just A squared minus B squared. Yes.
Pythagorean theorem. But how do we express it?
Oh, I just said the square root of A squared minus B squared comma B.
And what you're really, it's not this triangle, it's this triangle.
Right, that triangle right there.
Because this x value right here is what we need. You get that?
Yeah.
Okay. But we do know that this side would be B. So how big is x? It's Pythagorean theorem.
Yeah.
Now, it's the right angle. So let's see, that's a leg and that's a leg. So it would be x squared plus b squared equals a squared. Other side. So we get x squared is equal to a squared minus b squared. And then
What's the square root of A squared?
there you go.
So it's A squared minus B squared plus A.
Yeah.
No, that's it right there.
That's the
Well,
distance of
for
A.
the-
That's for this one.
Yes, and then
And
the
then
second
A
one, you
plus
just
A.
take you just add A, because that's how you found the one on the normal.
There you
Doing
go.
a parallelogram.
There you go.
form.
You did it. Very nice. That makes sense?
Took a while.
That did take a while.
Totally did not have to rip up my first sheet and rewrite all my problems on the second one.
Well, it was fun. All right. 1 through 10. All right. 2 answers on 1, 0, B, and A0. Hopefully that made sense. Number 2, 1 well, it's two answers technically. C plus E comma D, 1 point. Number 3, 2 points. Negative F, 2F, and F, 2F. Number 4, just 1 point. G plus H divided by 2.
Over J, comma J.
And comma J, but they gave you J. Number 5 is H plus M comma N. 6 is N minus P comma Q. We beat 7 to death, and we beat
Wait,
8.
what's number 5?
We didn't do 8.
What's number 5 again?
H plus M comma N.
Oh, okay. Sorry.
We didn't.
We didn't do 8 though. 8 is 3 comma 4 and 8 comma 4. We
3
did.
comma 4 and 8 comma 4?
Yep, and we did none. On 10, a whole lot of answers here. A, W plus T comma Z. B is U comma V. C is, where's the answer? Oh, good Lord. C is F comma G. D is U plus W comma V plus Z. E is T comma 0. F is, I don't see F. Where's the answer to F?
F's the exact same thing as C.
Yeah.
You are
And it's the
correct.
same thing as G.
And then I gave the wrong answer then. Now I see what it makes sense.
Yeah.
They wrote C comma F comma G, and I was thinking the answer to C was F comma G. So I gave you the wrong answer to C. The answer to C, F, and G are W plus T plus U over 2, comma, Z plus V over 2. Now that makes sense. That was C, F, and G. And that's it.
Yep.
How come you didn't stop me on C when I
Because
said
I
it was
wasn't
F
paying
comma G?
attention.
I wasn't paying attention.
Okay.
I
Well,
was
clearly,
confused.
I was like, oh, I know I
Clearly.
got 10 right, and then I'm like,
Yeah.
when I heard you stumble, I was like, wait, did you see C right?
one for you. We are only doing 2 proofs today.
How many homework questions?
5,
Oh, good. That's actually good.
and they're all proofs.
They're all hard. They're all proofs.
No, they're very.
they're not hard.
I'm gonna literally show you how they're done with these 2 proofs that we're actually gonna do 3 proofs, but 2 that I want you to write down. Nothing to put in your book of truth. We talked about all that. Field day Friday. 8 problems.
8?
It was 5 for my regular classes, 8 for you.
That's baloney. This is heresy. Yeah, heresy.
Who am I being heretical to?
But 8?
Who am I being heretical to? What's the definition of heresy?
The definition of heresy is something that is not within common beliefs or an outsider to the original faith.
I'll go with your second part there.
Technically, the first part can be achieved.
Because if you're not part of that faith, you can't be a heretic.
That's why Yeah, you're right, Mr. C. Wow, you're so smart.
Thank you.
Some of the sarcasm.
You're welcome.
He's the one who went to college.
Ooh. I'm the one who's read the dictionary 5 times in my life.
Oh, well done. You're good at math.
I know, I'm not.
Before the internet, well, actually, it wasn't before the internet. Before common people had the internet,
Mr. C's gonna
there
go
were
on a
these things
tangent
called
again.
encyclopedias. Encyclopedias was the Wikipedia of my generation, or your generation, sorry. So Wikipedia, it has information on everything, but we don't know if it's a trusted source. Back in the days, they gave you these 20 books, and it went from the letter A all the way to the letter Z. And you're like, well, that's not 26, because they would combine some letters that didn't have a lot of words. But it was basically Wikipedia in book form. And so I spent my days just reading encyclopedia because I always found it fascinating. I did have a friend in the Army who read the dictionary, and he literally, that was his thing. That guy could give you the definition of any word, and he had the dictionary memorized and the spelling, and he was pretty impressive, but that's all he could do. He was a horrible worker. He didn't have much common sense, but he had the dictionary memorized, and that was his thing. Yeah.
This is a bit off topic, but I just want to ask you. You can think about this for a while.
It has
Is
something
it-
to do about being 10,000 feet under the earth.
No, but it has something to do with this chapter.
What?
Is it possible to get a square with only one variable?
Yeah, a square will
No,
have only
no,
one
you did
variable.
Did that with 3. Number 3. F, negative F2F, F2F.
With no x or y axis, so no zeros. You only have variables, and the only variable you have is a. Is it possible to find the other 3 coordinates but only using a?
I mean, you can know the.
If you knew a side, the answer is yes. You got to know the distance of a side. Because then no matter where you put one of the corners, you can calculate the other corners.
That's a good point.
All right. Here we go. Coordinate proofs. We finally get to the end of the chapter, and this is the class on the coordinate proofs.
It's
So
the end.
it is, and it's literally for us, it's going to be for us, it is the end of the book. So today's the last class. Go figure. Thank Miss Allen for that. So last class, we took coordinate plane, we put a shape on it, we came up with the coordinates of the vertices. That was the whole thing. So we do this so that we can do these things called coordinate proofs. A coordinate proof is you try to put the shape so that you have the least number of variables. Why? Because it makes the proof a whole lot easier. So we two main techniques. We use the origin, we use the axes, and the last part is the hardest one. You try to think ahead in the proof. And because I'm going to show you 2 proofs, you're going to be able to think ahead tonight of where you need to place it. I think 2 of the proofs, they go ahead and put it on there. The other ones, they don't. Like you're going to have to be the one that puts it on the coordinate plane and come up with all the coordinates. Last night you didn't have to come up with all the coordinates. Today we do. All right, so this is hard because how do you think ahead? You don't even know where the proof is going. That's the challenge. I'm going to show you something that looks like a proof. It's not a proof. But here we go. All right, so think about this. So I got a shape that I put on the coordinate plane. I'm going to tell you that this shape right here, triangle, is isosceles. I'm telling you it's isosceles. How do we prove that?
You already told me.
Yeah, I know, but how would we prove it? If I didn't tell you it was isosceles, how do we prove it?
You would have to say that the angles are congruent.
We could, from way back when, chapter 4. If we show that angle O and angle Q are congruent, then it's isosceles by the converse to the isosceles triangle
Or
theorem.
the distance between PQ is the same as the distance between PO.
So if we could show that OP is equal to QP, it's isosceles, right? Obviously, in this chapter, we didn't do anything with angles, so we're going to choose the second method. So I got to show that OP is equal to QP. How do we do that?
Distance theorem.
Notice we already have the points here, right? So pretty easy, distance. So let's do that. Can you do it in your head?
Square root of 3 minus 0. So square root.
No.
Yeah.
Distance formula is square root of what?
X2 minus X1.
Okay,
So it doesn't matter because it's a plus. It's
but
commutative.
it's squared.
It's commutative.
Agreed, but it's not 3.
It is 3.
So why?
I'm saying 3 minus 0 squared.
Oh, no, that's not what I heard.
That's what I said.
Okay, Keep
3
talking.
minus 0 squared is 9.
okay, that's what I'm
And 4
thinking.
minus 0 squared is 16.
So it's,
So it's 9 plus 16.
which is,
25.
so OP is
5.
5. How long is QP?
5.
How do you know?
Because there's no way that you're going to tell us this and then it's not going to be true.
If only that were possible. You'll find out that yes, that is true. However, mathematically, why is that true?
3 minus 5, 4 minus 8. So you get negative 4 and 9 again, and then you get 25. No, you get negative 4 squared and 9.
There we go. All right, which gives us, once again, 9 plus 16, which is 25. Okay, did everybody follow that logic?
Yes.
Okay, cool. So we got that they're equal. So it is isosceles triangle. Okay. We haven't done this. This is an actual proof. You see the 2 blue lines that we haven't used?
I'm blind.
Those are equal.
Are they are medians. And remember, median goes from a vertex to the middle of a side. Okay, so they're medians. For an isosceles, for this isosceles triangle, are these medians congruent or equal?
Yeah, they are.
Well, how would we know?
Well, I mean, you could find the midpoint if you wanted to, but I mean, you could say that since they're
Okay.
equal, it goes to the middle.
No. I didn't say they're equal. I said, are they equal?
Since OP and PQ are equal.
Since they are equal,
since OP and PQ are equal,
Okay.
then the midpoints will be at the same x-axis.
No.
Yes. Because if it's,
No.
that means it would be parallel.
You're close, but it's not the x.
A Y.
Oh, yeah, the y.
Okay.
So
All right. So their y values have to be the same.
if their y values are the same, then so both of the x values, well, dang it, no,
Why don't we go with your first thought, which was
then what do you mean?
you gave us another way of doing it.
Say that they can congruent by finding the midpoint of both of those?
Yeah, let's do that. Wouldn't that be easier? And then find the distance.
Maybe you could do that.
Okay. Allie? S. Midpoint. What's the midpoint? And the reason why we can say it's midpoint because I'm telling you the blue is a median. So where is S? Midpoint off the top of your head? Formula?
X1 plus x2 over 2, comma, y1 plus y1, y1 plus y2 over 2.
Take two x values, add them, divide by 2, take two y values, add them. So where is S?
S is in the middle of OP.
Okay, and what are the coordinates?
So it's 2, 3 over 2.
Yeah, ugly number. Okay, I'm gonna write, suspiciously, I'm gonna write 1.5. And you're like, wait a minute, you told me to always leave it as a fraction, as a fraction.
You did.
Okay, well, you can. All right, McKinley, where's R? And R is a is the midpoint. So where is R?
R is the middle between 4/3 and 4, 3 and 8, 0.
So where is that?
Well, I have to do some math.
Okay, what math would you have to do?
Well, I have to do 8 plus 3. and
8
0
plus
3.
8
No,
plus.
sorry, 8 plus 4.
That's 12.
Yeah, 3 plus 0.
That's
Right.
3.
But you put 3 and 12. You put 3 before 12. Oh, divided by 2 as well.
Okay, so 12 divided by 2.
That is 6.
Okay, and then
3 divided by 2.
there's 1.5 again. Okay, cool. So we found those points. So 6, 1.5. Now what?
Now,
What were we trying to do?
You have to find the distance.
You gotta find the distance.
0, 0, and
Okay, so here's your first ugly thing that you can't do in your head.
I
Right?
mean, arguable.
Okay, so what do we got to square?
I could do that in my head.
What do we got to square?
6 and 1.5.
Well, I can square 6. What's 15 squared?
225.
So what's 1.5 squared?
So 2.25
Okay, so now you can do it. So what are we supposed to do with those numbers?
is that's the square root is 36 plus 2.25,
Which would
is
be?
38.25.
Okay, so one of them's 38.25. What's
And
the other one?
is inevitably going to be
Well, you're gonna prove it.
8 minus 2 is 6, and then 1.5 squared.
It would be the same thing. Okay. So we just proved it, right? We proved that the medians of a isosceles triangle are actually congruent. By the way, we never proved that in class, and we just did. And I'm just going to point out, does it look like we're doing geometry, or does it look like we're doing algebra?
Algebra.
And that's what a coordinate proof looks like. This coordinate proof, it looks like we're doing more algebra than we are doing geometry. Okay. The other thing, too, is you get some really ugly things that happen in algebra when you do a coordinate proof. And you got to be okay with that. Like, okay, I'm getting really ugly numbers. It couldn't possibly be this number, and it ends up being that number. And no, you can't do the math teacher intuition. Like, of course it's going to be congruent because you're asking me to prove it.
Well, I mean, it's true.
So great, we just proved for this isosceles triangle that the medians are equal. Did we prove it for all isosceles triangles?
no,
Okay, so guess what we have to do?
put it in every isosceles.
So the first proof we're gonna do on your paper, we're gonna prove it for all isosceles triangles. So guess what we have to change?
The numbers.
All we have to do is change the numbers, literally.
Put in X's and
You
B's.
put X's and A's and B's and C's. So let's do that, okay? Let's do that. So this is number 1. There we go. I took away all the coordinates. Now let's plug them back in. So pick one, McKinley. Pick one of the vertices. Tell me the coordinates.
O would be 0, 0.
Thank you for choosing the easiest one. Yes. All right. Anna, pick one. So she's going to choose that. It wouldn't be A comma B.
Oh, 8, 0.
would be if we choose that A. I don't know if I chose that or not. I think I did. So if she chose A for the Q, then where's P?
P or B, comma C.
A over 2 comma B. A over 2 comma yeah.
Yeah, and that's why I didn't choose that one. Same logic. I'm just going to do P first. So P is going to be at,
A, comma B.
just because I don't like fractions, so therefore her way would have worked, and it will work. It's just never deal with fractions you can get away with. Therefore, that's going to be 2A. Okay. Same idea. Same idea. And this is one of those, once you start doing coordinate proofs, you're like, yeah, I know what's going to happen if I choose this point first, and that turns that one into a fraction. Don't want to do that. Okay, cool. The rest of the proof literally is exactly the same. Like we're gonna do this exactly what we just did in the previous one. What was the first thing we did?
We figured out the distance between O and B.
Yeah, but in order to do that, we need
the distance formula,
in order to do that, we need
the slope formula,
no, we never did slope.
the square root.
You need the distances.
We need the midpoint.
I thought we did distance first.
Well, the first thing we did was prove it was an isosceles triangle.
Oh, okay. All right. We don't.
But now I'm giving you it's an isosceles triangle. Remember I said what kind of triangle is it? And we proved it was isosceles because it was the.
Yeah, no, I'm not thinking about that. I'm thinking about something else.
Oh, okay. So we need to find S and R first. Okay, this is going to get really ugly. Don't panic. It's just ugly. So S, where is S?
A over 2, comma B over 2.
No, we can't get away with that fraction, right? Don't panic. It's just a fraction. Where's R?
Is 1.5A comma B over 2.
And I'm going to leave it in fraction form. So what would it be?
3A over 2.
Okay. And B? All right, sorry. The Y value?
B over 2.
Okay. Everybody okay where we're getting that?
Yeah.
You could write 1.5A if you wanted to. All right, cool.
Yeah.
Now what do we want to do, McKinley?
Now you want to find the distance.
Okay, so you're going to be dealing with distance formula, some really ugly stuff here, but don't panic. All right. No one's going to do this in their head, but tell me what to write.
I can do it.
Square root,
Do OR first.
0, or, yeah. Or B over 2 minus 0.
She's doing her Y's first. He had mentioned it's commutative. Whenever you do the distance formula, like what comes first, the X's or the Y's? Well, remember you subtract, then you square, then you add. So if you want to do the Y's first, you can. Right. So if you do the Y's first, it would be
B over 2 squared.
B over 2, that whole thing squared, because it's B minus 2 minus 0, point squared, and
3A over 2 squared.
because it would be minus 0. So I did my X's first, but it's the same darn thing. Okay. Well, then it's just that squared and that squared. So when you square that, what do you get?
9A over 4.
No.
Oh, 9A squared.
Yes.
Over 4.
And
B squared over 4.
okay. Hey, we got common denominators. So therefore, you would get
9A squared plus B squared.
all over 4. Now, if we wanted to take the square root of 4, we could. But here's the point, and this is I spent some time in my non-honors classes, that this is going to cause a lot of people some problems. They're going to like, oh, I've done something wrong. Look, you're expecting an answer of 1.5 or 6 or something. You just get it's a coordinate proof. You're going to have a whole lot of variables floating around. It's okay. If we can find that the other one literally equals this right here, we're solid. Yeah, I could change this and simplify it to the square root of 9A squared plus B squared over 2. Perfectly fine. But as soon as I get it down into this form right here, I'm going to stop and see if the other side turns into this or not. Okay. If it was factorable, I might do something with it. This one's not factorable. The quadratic is. Okay. All right. So QS.
So going to be 3A over 2 squared and B over 2 squared.
Where are you getting that from?
So you do A over, oh wait, I added.
You did.
So
because we got to do subtraction. Now be careful, it's not even that, because this isn't over 2, so it's not common denominators. So we actually have to, which one are you subtracting? Which direction are you going? And you can go either way, just what's your point 2, what's your point 1, that sort of thing.
2a minus.
So she's doing 2a minus a over 2, and then it would be 0 minus b over 2. I'm not sure if I did it that way or not. Yeah, I did that way too. Okay. We got to get common denominators. What's the common denominator? 2. So how do you turn that into a 2?
Times by 2.
So you get 4a over 2 minus a over 2, and we actually get 3a over 2, which you thought you got, and I knew you did because I knew you added. But we actually subtract, and we still get 3a over 2. That's kind of weird. All right. So we got 3a over 2, but it's got to be squared. So what's 3a over 2 squared?
9a squared
Over 4. And over here we get
b squared
over 4, which you can actually stop right now because you can see that they're literally exactly the same. All right, common denominators if you want to. Cool. They're the same. This is the hardest thing, is because this is a whole lot of messy stuff going on here in algebra, and there's no real numbers except for a 9 and a 4 and a 3 and a 2. But yeah, we just proved that for any isosceles triangle that the medians are congruent. It says equal. Oh no, it says congruent. There you go. And by the way, that is a proof, an honest to God proof. Certainly looks like algebra, but it was a proof.
So for coordinate proofs, do you not have to write it in like the
Nope. If you were in college or if you become a mathematician, you were doing this, you put this in word form. So you'd write, everyone writes paragraph proofs, simply because that's the way we read things, right? The two column proof is great for high school because it gives a comforting factor of a procedure. But the reality is you just kind of speak, hey, imagine if I had, like I'm talking to you. Imagine if you had an isosceles triangle placed upon a coordinate plane. I'm writing the proof just in a paragraph form. But this would be perfectly fine as a proof as it appears visually right now on the board. I might put the QED on the bottom here, just so you got to be able to, for your reader to be able to read your work. All right, cool. So the basic technique to show that medians are congruent is the distance formula, basically. But in order to use the distance formula, it looked like we had to use the midpoint formula. You're going to, Kate, you might run into this. Do you remember what a diagonal is?
No, could you please remember what a diagonal is?
Give me a shape.
I know.
Polygon. Square. What's the diagonal of a square? A diagonal goes from a vertex, not to an adjacent vertex, but to a non-adjacent vertex. So from there to there, that's a diagonal. So if you have a hexagon, definition of a diagonal is a segment that joins a vertex to a non-adjacent vertex. So this one is adjacent. If I go to there, I just basically made a side. When I go to a non-adjacent vertex, those are your diagonals. I say this because guess what tonight? Instead of doing medians, you're doing a diagonal. I mean, by the way, it's the same idea. Okay. Not the diagonals are the same as a median, but it's basically distance form. Okay, cool. We're gonna do one more. We've proven this before chapters ago, but we're gonna do this one again using a coordinate proof. Okay. What's the shape?
Triangle.
Triangle. Tonight they're gonna give you a trapezoid, I believe. For those of you already doing your homework. Okay, it's gonna be the same basic idea. We are supposed to prove that for a triangle, right? That if you connect the if you connect the midpoint of two of the sides of the triangle, that this blue line that I just created, MN, is parallel to the third side, and it's also half of the opposite side. Do you remember this theorem? This is called the triangle median theorem. I don't know what number, but that's what it was called. Cool. So how many things do we got to prove? in this one proof?
Two.
What two things?
First, to prove that,
It's parallel to
Okay, so I gotta prove it's parallel.
and then you gotta prove that the top base minus plus the bottom base divided by 2 equals that.
Then you gotta prove that it's half of the length of the
Or you could prove,
You're doing a
That it's
trapezoid.
double.
Which is,
yeah, either prove that MN, if you double MN, you get to the bottom, or half of the bottom is that one. Either one's fine, right? So let's do parallel first. How do you prove the two things are parallel?
I don't know, how do you?
Angle
What?
or opposite angle.
No. Oh, I see. Yeah. If we could show, and that's the way we proved it in that chapter, if we could show that this angle right here is congruent to that angle right there, okay, they're parallel. I have no angle measurements. Don't know. So how do we prove that they're parallel? It was from this chapter. We didn't do anything with angles in this chapter at all. How do we show that two things are parallel?
Slope is the same.
Slope is the same.
Oh, okay, that's easy. Because then you have both of the x coordinates. You just see the trapezoid, and then you can say that since they have the same x coordinates.
Do they?
Yes.
How do you know?
Because it's parallel to 0, 0.
No. That's what we got to prove.
It is parallel to 0, 0.
How do you know?
Because he's asking me to prove it.
That's true. I've never asked you to prove something that wasn't true.
You should start doing that.
How about we start off easy? What's the slope of OQ?
0.
Zero.
How do you know?
Because
Oh no, it's 1. No,
It is 0. How do you know?
it's a horizontal line.
Well, how do you know?
Because it is the x-axis.
Because it's the x-axis. Okay. So we know that OQ. Clicked on you. Oh, I signed it. All right. So it's not isosceles. It's just a triangle. So P is AB. What's Q? It's just a triangle.
0,
C,
C comma 0. Okay. Make sure you don't mix up the 0. Okay. We know that OQ is got to be equal to 0 because it is the x-axis. So now what do we need to prove? To show that the two things are parallel. We're going to show
the slope of MN
is
0.
0. All right. How are we going to do that?
Find the coordinates of MN.
We got to find the coordinates of both M and N so that we can plug those values into
The slope
the slope formula, which was what?
y2 minus y1.
There you go. Okay, so where is M and N?
Okay, you're just making me happy.
So where's M and N?
They're you can figure out using the midpoint formula.
Yeah, we are told that they are midpoints, so we can use the midpoint formula. Okay, which one do you want to do first?
A plus C over 2, B plus 0.
Which one do you want to do first? Which? M. Where's M?
Yeah.
In the middle
So I
of
don't
the-
have-
Okay, so what are the coordinates? How do you figure midpoint?
A over 2 comma B over 2.
Okay, so you take the two values or the two coordinates and you add the x's divided by 2, add the y's divided by 2. So what's the answer?
A over 2, comma B over 2.
A over 2, B over 2. Okay, great. If you want to see the math, there's the math. Well, it'll be 0 because one of them is at 0, 0. But we get A over 2, B over 2. Where's N? Ooh, this one's a little bit
A
ugly.
C over 2. or
A what?
Plus C.
A plus C over 2 and
B over 2.
B over 2. Okay, not very comforting or a satisfying answer, but that's what it is. And what are we trying to prove?
At the slope of
Okay, now everybody stop and do look at the board. This one's ugly. So what do we really have to do? Now,
plug those into the slope.
okay, so what's y2? Here's my 2 points.
B over 2.
And what do we got to do?
Subtract it by
And then we got to take the x values. Now look at the board and tell me why you shouldn't panic at this point. That's what she just told me to do.
this thing's
Why shouldn't you panic?
This thing's canceled.
Well, it doesn't technically cancel, but why am I not panicking at that big honking mess right there?
Because there's no need to panic.
Look at it. Why am I making that statement? Why you shouldn't panic?
I don't know why.
Because both things cancel. You gotta-
Nothing cancels. Cancel means it gets rid of it by multiplication or division.
slope of MN, it's just 2's. I mean, it's just halves.
Why am I not
You don't
panicking?
have to do anything.
Yeah, but look at it.
There's nothing to do.
Oh yeah, 1.
No.
Zero.
So you get, do you see it?
Zero on the top.
You get 0 on the top. Now, when I uncover the bottom, guess why I'm not going to panic?
Because it doesn't matter, because you got 0 on the top.
Because it doesn't, well, it does matter if the bottom
It doesn't put 0.
is the bottom 0. That's the only thing I would panic at. How do you know it's not 0?
Because it equals C. Because A.
How do you know the bottom isn't 0?
Because if you do the math, it just comes out to.
Okay, but you got to make a logical argument here.
Well, let's see. A and A cancel because you.
They don't
subtract them.
cancel.
And then 2 and 2 disappear because you subtract them.
Is this fraction the same as this fraction?
No.
How do you get a 0? How do you get a 0 mathematically?
Because they have the
If
same
you're,
bottom.
if you have, no, that's not true.
If you have the same fraction.
If you have the same fraction, it's like saying 1/4 and 2/4. I don't care if you add or subtract, you can't get a 0. The only way you get a 0 if it's 1/4 and 1/4. You get a 0 if you subtract. So on the top, notice, literally, look, it's the same thing. A b over 2 and a b over 2. So when you subtract, you get a 0. We have to be concerned with the bottom. If the bottom is 0, it's a vertical line. Okay? But it's a plus c over 2 and the other one's a over 2. They're not the same fraction. This is the hardest thing to wrap your head around because if you get this on a test, you're going to look at it and like, woe is me, I don't know what to do. You got to be able to logically think that one through. Okay, great. I get 0 on the top. I get something on the bottom, but it doesn't matter. It doesn't even matter if it's negative or positive. It just matters that it's not 0. And therefore, the slope is 0. Halfway there. Now what?
Now we have to prove that it's half the length
Okay, so what are we going to do?
of either distance.
Distance formula. Okay? What do you want to do first? The small one or the big one?
Small.
Small one, distance formula.
Would be the square root of a plus c over 2.
I think I did the longest one first, but we'll do the shortest one first. Say again? Square root of, let's finish this one.
A plus c over 2 minus a over 2.
Minus a over 2 squared plus,
Plus 0.
so it goes away. So look, common denominators. So what do we get?
And
6.
C over 2.
And it's squared, so we get,
C squared over 4.
and it's the square root of c squared over 4. So what do we get? Take the square root. Over, we get c over 2. So this part right here, we got the distance is c over 2. Okay? For this to be true, what do we got to get on the bottom?
2c.
2 over C.
C over
2.
It'd be double that if it's true.
C over 4.
No, double.
C squared. 2C over
C.
4.
Just c.
Oh.
Times that by 2 and it's c. So how long is O2?
Technically, 2C over 4 is double.
C.
No,
Yeah, it is.
Yeah, it is.
No, it's not. It's just C
it's
over
not.
2.
That would be a half c.
You'd have to have 2C over 2.
Fine.
Look, it goes from O to Q and we're sold at C, so it is C and you're done. All right, you're gonna have to do both of those tonight when you get to the trapezoid.
You want our homework?
I do want your homework. All right, so for Madison and whoever else is, no, it would just be Madison. This is the math that we just did. OQ is the value C by its very definition, and then MN, as Allie did the work, as you saw. Your dragon has chicken pox.
So,
No, McKinley's dragon.
oh, sorry. I'm not even there.
But you don't like them now.
We only have 5 kids in the class. We wiped down the 5 desks. If there were, because the previous class, every desk was occupied. So the spray is left from 2 periods ago. Hey, where were you this morning? Did you have fun?